So today we're going to talk about antiderivatives of polynomials called indefinite integrals. The reason these are indefinite integrals is because we've seen so far that a definite integral can represent area under a function or area bounded between a curve and the x-axis as an accumulation or a loss. But you can think of integration as antiderivatives, so basically reversing the derivative process. The thing is, we have different types of functions that might have the same derivative. For example, the function f of x equals x squared plus 100, and the function g of x equal to x squared minus 1,000 are drastically different functions when it comes to the actual values of the functions themselves. The f of x function that we've described would have no x-intercept, but the g of x function would definitely have two x-intercepts, and the individual values for all of the points are going to be different. However, f prime of x and g prime of x would both equal the same values. Both derivatives are 2x using the power rule. So that means on the f of x function at x equals 0, we would have a 0 slope. And on the g of x function, we would have the same slope. It doesn't mean the values of the function are the same, but the slopes at those particular x values are the same. So we would have corresponding slopes at every point where the x value is the same. So when we do indefinite integrals, we have to account for the fact that if we were to instead start with the information that we had two different functions with the same derivative, what would the functions be? So it's kind of the process or idea of recognizing that 2x is the derivative of x squared, but there could be a constant out there. So both of these would have an antiderivative of x squared plus c, where c is an unknown constant. So notation-wise, this skinny s, summation symbol, sort of, is basically asking us for the area. It's the y values times the width of the x's, which we know represents a base times height, or an area. But it also represents the integration symbol, saying if we go backwards from f of x, we would get the original function of a higher power. So if we take the derivative of capital F of x, then it would come out to be the smaller f of x. One way to think about this and try to keep the concept straight, derivatives versus integrals, is that if my function were a velocity function, its units might be, for example, meters per second. So if we integrate velocity with respect to time, we are multiplying the minutes per second, that's the velocity, times the dt, which is seconds, and that gets us back to a position or displacement function. So the integral of velocity gives us a position. So I like to think of that as just recognizing that position, if you take the derivative, becomes velocity, and if you take the derivative again, you get acceleration. So going down this list would be differentiating. If I were instead to go back up the list, I would be integrating. So multiplying meters per second times seconds gives me position. Similarly, if I had acceleration in meters per second squared, and I integrate dt, I'm finding that area cancels, and I get back to velocity, which is meters per second. Now we recognize that we have the derivative of any constant we know to be 0. That means if we integrate 0, we just get a constant. So we're reversing the action. If we take the derivative of a constant times x, such as y equals mx, then we get just the constant. So if we integrate the constant, we get the constant with the x back, plus c, because again, if we had y equal to 3x plus 4, or y equal to 3x minus 5, both of those would have a derivative equal to 3x. So if we're going to reverse that process, both of those would have a derivative of 3. Getting a little ahead of myself. So if we reverse that process and we were to integrate 3 with respect to x, we're representing that area. So x times 3 basically becomes 3x, but plus c. Because if we're just starting with 3, we have no idea which one of these original functions we need unless we have more information. So the fact that we don't have more information is why we call these indefinite integrals. So similar to taking the derivative of addition and subtraction was just normal, integrating with addition and subtraction is also normal. We can do them separately, but we do need to remember that plus c. Now, when we took the derivative with the power rule, we brought the n to the front, and then we subtracted 1 from the power. We have to do this in exactly the opposite direction. So the first thing we did, number 1, we multiplied by the power, and the second step was to reduce the exponent. We must reverse this exactly. So we have to first add back to the exponent, going in exactly the reverse order, and then we divide by the larger power, the new power that we have. So over here, remember, we were multiplying by the original large exponent, not the n minus 1 reduced one. So we're going to add 1 to get back to the original power, and then divide by that original large power to undo the original multiplication. We still need the plus c because, again, we don't know if we had x squared or x squared plus 5. So some examples in general. If I have 7, this integrates back to be 7x plus c. I can check because if I take the derivative of 7x plus c, I get just plain 7, and the derivative of a constant is 0. For the power rule, I'm going to add and then divide. And then I have to remember my plus c. So again, remember, if we were taking the derivative, we would multiply by 6, which would cancel, and subtract 1. We have to go exactly in reverse. We have to add and then divide. So again, we're going to add to the 12 to get 13, and then divide by 13. We're going to add to the 4 to get 5, and then divide by 5. Because addition and subtraction are normal, I don't have to do any special rule. I can just subtract. I'm going to add to get 3, and then divide, plus c. That's my constant of integration. T cubed, I'm going to add. I get t to the 4th, divided by 4. I have t to the first power, so I'm going to add and get t to the second power, divided by 2. And 1 goes backwards to become t to the first power, because the derivative of t would be just 1 with respect to t. I need to remember my plus c. So multiplying by a constant is not the product rule. Okay, so it's not the product rule, so we don't have to try to undo the product rule when it's a constant times x. It's only a product rule when it's two functions, not just a constant scalar multiple. So I can hold the 10, take the x to the 4th to become x to the 5th, and divide by 5. I can hold the negative 2, x squared becomes x cubed, divided by 3, and then plus c. Of course, on our multiple choice question, you would have to simplify this out to be 2x to the 5th minus 2/3 x cubed plus c. Okay, so for number 7, we're going to hold the 2, raise the power, and divide. We have minus 7. We have x to the 1st raises the power to 2 and divide by 2. 8 becomes x to the 1st and then plus c. So if I hold the 3/4, becomes x to the 6th divided by 6. Hold the 5/3, x cubed divided by 3. Hold the negative 1/2, it's really what dividing by 2 is, and then x squared divided by 2, and then plus c. So on a multiple choice, this would simplify out. 3/24 is 1/8, x to the 6th, plus 5/9, x cubed, minus 1/4, x squared, plus c. Okay, now remember, pi and e, Euler's number e, are just constants. So I hold the constant, and this becomes x squared divided by 2. This is a constant, and a constant goes backwards to be constant times x plus c. So similar to when we were doing the derivatives, we would rewrite anything that was in the denominator, if possible, as just a power rule. So I'm going to rewrite first. This is going to be x to the negative 2 dx. I still use the power rule, so adding to negative 2 becomes negative 1, and divide by the new power, plus c. So on a multiple choice, this would be negative x to the negative 1 plus c, which would simplify out to negative 1 over x plus c. Be very careful that you don't think that this negative power and this negative constant scalar multiple are going to cancel. They don't affect each other. Okay, so my rewrite for number 11 is I have 4x to the negative 3 minus 5x to the negative 4 dx. So I simplify when I'm anti-deriving. I'm going to add, so I get negative 2 divided by negative 2. Minus 5, and I add to get negative 3 divided by negative 3, and then plus c. So I have negative 2 over x squared plus 5 over 3 with an x cubed in the denominator plus c. Okay, I can still rewrite rationals. This is going to be x to the 1/2 power dx. Remember, this notation is extremely important. You're representing the multiplication of the units. So you can't leave this dx off. A lot of students want to be lazy about that and leave off notation. And leaving off notation is one of the costliest things you can do on the AP exam. Okay, so if I integrate, I'm adding So I get 3 halves, and I'm dividing by that 3 halves. Dividing by a fraction is the same thing as multiplying by the reciprocal. And you would typically see the multiple choice answer left with a fractional exponent. You don't see them left with negative exponents, but you do see them left with fractional exponents. For number 13, we're going to hold the constant and rewrite. So I have y to the 1/3 power and y to the 1/4 power this time as part of my integration. By the way, this entire thing is called an integral. If you just have this inside part, that's called the integrand, but it's not a complete integral without the indication of our variable. So it's perfectly okay. This is not going to be implicit integration by any means, as long as the variables match. So remember, implicit differentiation was if the variables did not match. So since our dy is telling us what to do with respect to, and we have y, this is just a normal integration. So 2y, when I add 1, I get 4/3 divided by 4/3. Hold the -4, 5/4 divided by 5/4 plus c. So dividing by a fraction is multiplying by the reciprocal. So I'd be multiplying by 3/4, and I have y to the 4/3. I would be multiplying by 4/5, and y to the 5/4 plus the c, don't forget that. So now if I simplify, this becomes 3 halves y to the 4/3 minus 16/5 y to the 5/4 power plus c. For number 14, I'm going to rewrite again. This is x to the -1/2 power minus x to the 2/3 power. Still a dx problem this time. So when I add, I get x to the +1/2 divided by a half, which I know is multiplying by 2. When I add to 2/3, I get 5/3. And dividing by 5/3 is multiplying by the reciprocal. So I'm going to start skipping some of the basic algebra steps. Okay, remember what we said about pi being a constant, so kind of think of this as pi as being 3, but please do not start trying to turn pi into a decimal. That's not allowed. You need the exact answer. So I'm going to add 1, and adding 1 to pi is just pi plus 1. I'm dividing by the new power. So I'm dividing by the entire quantity of pi plus 1. It just can't be simplified. The square root of pi is a constant, so I'm going to hold that and add an x, and then plus c. And this is in simplest form. There's no radical or anything on the bottom. This is just the best we can do. Okay, so I want to make sure that you're being as clever as possible. Use the forest. So simplifying with algebra before deriving or anti-deriving can be one of the best tools. So this would be a chain rule derivative and a chain rule integral, which is much more complex. In simplifying this out, we don't even want to do the product rule. We're going to avoid the product rule for a while. So if I FOIL this out, I'm going to actually take the integral of 4x squared minus 12x plus 9. It almost looks like a 72. Let me see if I can clean it up a little bit. We're taking the integral with respect to x. So we integrate 4x cubed over 3 minus 12x squared over 2 plus 9x plus c, which simplifies to 4/3 x cubed minus 6x squared plus 9x plus c. Okay, now, notice you are never allowed to split the denominator, only the numerator. A lot of students have very bad algebra skills and think they can start canceling things off that don't cancel. If it doesn't factor, it doesn't cancel. So no factor, no cancel. That means we're going to have to split this up to do this correctly. So I really think of this as x squared is being divided by x to the fourth. 3x is being divided by x to the fourth. And 1 is being divided by x to the fourth, and our integral is dx. I'm going to rewrite as one power rule for each. So this is really x to the negative 2. Plus 3x to the negative 3 plus x to the negative 4 dx. And so far, all I've done is simplify the algebra of the problem. I haven't actually done my integration yet. So now integrating, I add and get x to the negative 1 over negative 1. That looks funny, so let's fix it. Plus 3 x to the negative 2 divided by negative 2 plus x to the negative 3 divided by negative 3 plus c. So negative 1 over x, add a minus 2 and a positive 3, so minus 3 over 2, and the x squared goes on the bottom. And add a minus 3, so minus 1 over 3x cubed plus c. Finally, it's also possible that you could do two possible things to simplify out. So I'm going to do both things. I'm going to distribute the top, and then I'm going to divide to simplify the powers. So just doing the numerator, I have 6x squared, so the first, plus 4x minus 15x, so minus 11x, and minus 10. And that's being divided by x to the 1/2 power dx. So simplifying, I have 6. When I divide, I'm subtracting. So this is x to the 3/2 power minus 11. Subtracting my powers again, I get x to the 1/2 power. Then minus 10, and since I don't have anything to move there, I'm just going to move this up to the top. Or I could think about it as having 0 on top and subtracting the half for my powers. So when I integrate this time, I get 6. It's going to be x when I add. I get the 5/2 power. Dividing by 5/2 is multiplying by 2 over 5. Minus 11x. I add and I get 3/2 for the power, and dividing by 3/2 is multiplying by 2/3. I get negative 10. When I add, I get x to the 1/2 power, and dividing by 1/2 is multiplying by 2. Gotta remember that plus c. So then I end up with 12 over 5 x to the 5/2 minus 22 over 5 x to the 3/2 and minus 20 x to the 1/2 plus c. Now, differential equations is a really fancy term for saying you have a derivative and an initial value given to you, and you'd like to figure out what the actual function is. So what happens if we know the derivative and we do know one point on the curve? So if we go back to that first page idea, if we said we only knew the derivative here, then we don't really know which of these original curves we're talking about. So we just put a plus c, and c is understood to be your constant of integration. It's your unknown constant because we didn't know. If we get a little bit more information, such as an initial value or any value on the curve, we can actually figure out which curve we mean. So remember, if you integrate f prime of x with respect to x, you're basically saying that you're going backwards from f prime, and going backwards from f prime gives you your original f of x. So that's the idea of what we're going to do. So if I go backwards from 3x minus 1 with respect to x, the integral of 3x is 3x squared over 2. The antiderivative of negative 1 is negative x, and I have to have a plus c because I don't yet know which function or parabola this point might be on. But now this point is enough to tell me how to figure out what the c value might be. And it's possible that the c value is 0, but not always. So that tells me that f of 2, which would be 3 halves 2 squared minus 2 plus c, must equal 3. So f of 2 equals 3. So if I simplify this out, I get 6 minus 2 plus c must equal 3. That means that 4 plus c has to equal 3, which further tells us that c is equal to negative 1. That means that I do know the exact parabola that has this derivative passing through this point. I know that my f of x has to equal the parabola 3 over 2x squared minus x minus 1, because my c was a negative 1, so that if I were to take the derivative, I would get 3x minus 1, but I would also be able to substitute 2 in for x and get the value of 3. So it makes both statements, the original statements, true. Okay, so similarly, my f of x is equal to the backwards antiderivative of f prime of x, which says we're going backwards from x squared minus 2x plus 2 in terms of x. So if I integrate, I get f of x, or antiderive, remember those mean the same thing, x cubed divided by 3 minus, well, the antiderivative of 2x is x squared divided by 2. I'm going to go ahead and skip because divided by 2 cancels. And if you want to double check, if you're going to take shortcuts like that, go ahead and check yourself. If I get x cubed over 3, then the derivative would be 3's would cancel, x squared. I would get negative 2x. I need a plus 2x, so the derivative of 2x would be 2. And don't forget the plus c. Now we're going to use that initial value. So if I substitute 3 in, I get 3 cubed divided by 3 minus 3 squared plus 2 times 3 plus c must equal negative 1. So we get 9 minus 9 plus 6 plus c must equal negative 1. So simplifying out, c equals negative 7. But the final answer is the solution. What is the function with this derivative passing through this point? So my final answer is f of x equals 1/3 x cubed, or x cubed over 3, both are the same, minus x squared plus 2x minus 7. Okay, so let's do a couple that are a little bit trickier. This time we're going to start with the second derivative, but this really works the same way. The first derivative is going backwards from the second derivative. Similarly to the function is going backwards from the first derivative. So I'm going to start by finding f prime by going backwards from the second derivative, which is just a 2 dx. So that tells me that f prime of x is equal to 2x plus a constant. I double check. Here's f prime. If I take the derivative of all this, I would get 2. And now I'm going to use one of the initial conditions. I'm going to use the f prime condition. So f prime of 4 is 2 times 4 plus c, and that has to equal 1. So 8 plus c equals 1. So c happens to be -7 by chance that it matches the last one. That's not intentional. That tells me what I can substitute in here, that f of x is equal to the integral of f prime, and I now know that f prime of x is 2x plus c, which is 2x plus the -7. I can write that down here if it makes it easier. So f prime of x came out to be 2x plus c, so 2x minus 7. So if we integrate f prime, we get f. So going backwards this time, we have f of x equals the integral of 2x is x squared, integral of -7 is -7x, and then this time I'm going to write this as plus d. It really doesn't matter what letter you use, but if you're going to use c again, you'd want to call it c1 and c2. Because we don't obviously, we've already said that c is -7, so come along later and saying c is something else is a little bit of an issue. So now I'm going to use the initial condition given here. F of -1 is -1 quantity squared minus 7 times -1 plus d, and that has to equal 2. Be very careful with your notation. If you put -1 squared like this, the AP is definitely going to mark off, which means I'm going to mark off. So please watch your notation. It's -1 all being squared, which becomes +1. -7 times -1 is +7, and then plus d equals 2. So 8 plus d equals 2 means d equals -6. So our final answer is f of x equals x squared minus 7x minus 6. So this is the function whose first derivative is 2x minus 7, which at 4 is 8 minus 7 is 1, and whose second derivative would then just be a constant of 2. And the function passes through -1, 2. Okay, so here for number 22, our f prime of x is the integral of f double prime with respect to x. That means that our f prime of x is x squared plus some unknown constant. Using the initial given information for f prime, if I substitute -5 into the square plus c, I should get 30. So 25 plus c equals 30. So c equals 5, and I know that f prime of x is x squared plus 5. So I can double check, does it meet the requirements? If I have f prime equal to x squared plus 5, does -5 give me 30? Yes. And does the derivative of f prime give me f double prime equals 2x? Yes. So now I can move forward, and f of x is the antiderivative of f prime of x. So that means we're doing the antiderivative of x squared plus 5 with respect to x. So our f of x function is x cubed divided by 3 plus 5x plus some other unknown constant. We'll call it C2 this time. Using my initial value, I substitute 2 in, so 2 cubed over 3 plus 5 times 2 plus some unknown constant has to equal -1. Notice I am never using a crossbar for multiplication. You can't use an x for multiplication. It's not allowed. That's a variable or it's a cross product. So 8/3 plus 10, which I'm going to rewrite as 30 over 3, plus the constant that's unknown, equals -1, so I'm going to write that as -3 over 3. So 38 over 3 subtracted makes C2 equal to -41 over 3, which is just an unfortunate constant, but that's our answer. So our f of x function is x cubed divided by 3 plus 5x minus 41 divided by 3. So this function passes through the point 2, -1, has the derivative of -5/30, because our derivative would be x squared plus 5, and the second derivative is 2x. Okay, so this is really the same thing that we had just done. It's just really written differently because it's so wordy. So we really have to kind of break this down and to get into a little bit of grammar here. Given that the graph of f of x passes through this point, okay, the graph of f passes through this point, tells me that f of 1 equals 6. If x is 1, the y value, which in this case is f of x, is equal to 6. And that the slope of its tangent line at any point is 2x plus 1. Okay, so this is not the function x f of x. The slope, prepositional phrase that says of its tangent line at any point called f of x, that's a prepositional phrase. If we had just said the slope is 2x plus 1, that would still mean the same thing because the slope of the curve and the slope of the tangent are the same. So as long as they don't say it's the normal slope or anything like that, the slope of the tangent is this. That really means that dy dx, or f prime of x, equals 2x plus 1. A little bit different on this is what they asked for our final answer. Our final answer is to find f of 6, not just f of x. So that just means we have to do a little bit more. So my f of x function is the integral of my f prime, which is 2x plus 1 dx. That means that my f of x function is x squared plus x plus c. They gave me a point on the curve that I'm going to use. So 1 squared plus 1 plus c equals 6. 2 plus c equals 6, so c equals 4. That means that f of x can only be x squared plus x plus 4. So if I substitute in 1, I get 6. If I take the derivative, I get 2x plus 1. Finally, what is the value when the function when x equals 6? So f of 6 is equal to 6 squared plus 6 plus 4. That would be my FRQ answer, even though it's easy to simplify. If it were multiple choice, I would have to work this out and get 46. So another way of asking basically the same type of idea, the acceleration function is 6t. When t equals 0, the velocity is 1. That means the velocity at time 0 is 1. When t is 0, the velocity is 1. So v is 1. V equals 1. And the distance is 3. So when time is 0, v is 1 and s is 3. So that means that s of 0 equals 3. Find the position function. So notice these are all s functions. So we know that going backwards, and we'll write it out, position, velocity, acceleration, down for derivative, up for integral. So think of down for d for derivative. So we know the velocity function is going backwards from the acceleration function. So we're going to go backwards from 6t with respect to t. That's going to give us 6t squared over 2 plus c, or 3t squared plus c. We're now going to use the initial condition for velocity that says at time 0, I will get 3 times 0 plus c must equal 1. So c is 1, which means my velocity function is 3t squared plus 1. Now going backwards from velocity will give me position. So I'm going to go backwards from the 3t squared plus 1 dt. So going backwards from 3t squared, I get 3t cubed over 3 plus t plus, I'm going to call this d. So I can double check. This cancels. The derivative of t cubed is 3t squared. The derivative of t is 1. The derivative of d is 0. So now that means that if I use the initial value for position, that at time 0, I would get 0 cubed plus 0 plus d has to equal 3. Because position at 0 equals 3. So d equals 3. And I have my position function is t cubed plus t plus 3. So answer C. Okay, another version. A particle moves along the x-axis so that at any time t greater than or equal to 0, its velocity is given. If the particle's position x equals negative 3 at time 2, where is the particle at time 1? So I'm going to think of this as position being x, and then velocity and acceleration. Surprisingly, the hardest thing for people to do is not use x as the input. This is really the output. It's telling me x at time 2 is equal to negative 3. Time is my input. So the input is 2, not negative 3. And then what it's asking for is where was the particle at time 1? Time is the input, so it's asking me for x of 1. So x of t is going backwards from velocity. So I'm going to go backwards from 5 minus 2t minus 3t squared with respect to time. So I get 5t minus the integral of 2t. I'll write it for you as 2t squared over 2. 2's end up canceling. Minus 3, and then t squared becomes t cubed over 3, and it just so happens that 3's cancel, plus c. So now I'm going to use that initial condition at time 2, 5 times 2 minus 2 squared minus 2 cubed plus c must equal, so x of 2 equals negative 3. So 10 minus 4 minus 8 plus c equals negative 3. So negative 2 plus c equals negative 3, so c equals negative 1. That tells me that my x of t is 5t minus t squared minus t cubed plus a negative 1. So x of 1, which was the question, the final answer we need, is 5 times 1 minus 1 squared minus 1 cubed minus a final 1. So 5 minus 3 is 2. Now 26 looks a little scary, but remember we can just FOIL this out. And if we FOIL this out, we are multiplying x to the 4th minus x times itself. So we get x to the 8th minus 2 x to the 5th plus x squared dx. So when we integrate, we get x to the 9th over 9 minus 2 x to the 6th over 6 plus x cubed over 3 plus c. So I can eliminate. So I have to make sure you're very cautious on this. This one definitely doesn't have enough terms. But you got to be really careful. A lot of students grab this one because of the 6, but we need to simplify. So we're really going to get answer C. Similarly, we can FOIL out this perfect square. So we get 9x squared plus 30x plus 25 dx. So when we integrate, we have 9 x cubed over 3 plus 30 x squared over 2 plus 25x plus c. So that simplifies to be 3x cubed plus 15x squared plus 25x plus c. D is the answer choice. Okay, so our final page. Before the practice part. The table below gives selected values of velocity of a particle moving along the x-axis. At time t equals 0, the particle is at the origin. Which of the following could be the graph of the position x of t for the time 0 to 4? Well, the first thing we want to start with is at time 0, the particle is at the origin. Okay, so it appears that they all have the origin for time 0. And then we want to consider what's happening. The velocity is not telling us the position of the graph, it's telling us the direction. So this tells me that I'm moving forward or up. This tells me that I'm stopped or at rest. This tells me I'm going backwards or down. This tells me I'm going up, and I'm going up steeper. Because remember, velocity is the slope of position. So this is really giving me slope values. So I'm going to look first for where I have a 0 slope. At time 1, I need to have a 0 slope. Well, that appears that it could be true for that one. Could be true for this one. Not true for this one. This is having a position value of 0. It's not having a slope value of 0. Okay. Here seems to be okay. And again, here, not okay. So I've eliminated choice C and choice E because neither of those have a 0 slope at time 1. I need to make sure I have a positive slope prior to 1, so we're good for all of these graphs. Whoop, I don't need that one. Don't even look at it. We had to have a negative slope at time 2, which we have here, and here, and here. We need to have a positive slope at time 3, which we don't have for this one, so we can eliminate A. And we don't have for this one, so we can eliminate B. And if we want to double check, we have a positive slope, a 0 slope, a negative slope, and at time 3 and time 4, we do have positive slopes. And notice what has to happen here. In order to cross between -1 and 1, we ended up having to have a 0 slope between 2 and 3. But even just looking for these slope values got us the answer that we needed. D. Okay, so for the next part, there's some practice that you're to complete. Please make sure you work through these and check your answers with the key.